Hey everyone! Ever stop and think about what the chair you're sitting on, the water you drink, and the very air you're breathing have in common? They're all made of the same stuff, matter, but they look and act so differently, right? Well, today we're going to be detectives and find out why. We're diving into the three fundamental states of matter: solid, liquid, and gas. Let's get to it.
So here's our game plan for today. We'll start with the big question: what even is matter? Then we're going to open up a case file for each of the three states and really dig into what makes them unique. And to wrap it all up, we'll zoom way into the secret world of particles to finally understand the why behind everything.
Okay, first things first, this word, matter. It sounds kind of big and scientific, but you know what? The idea is actually super simple. Matter is just, well, it's the stuff that makes up literally everything you can see and touch in the universe.
Now, if we want to get a little more scientific about it, for something to be called matter, it has to check two boxes. One, it has to take up space, that's what we call its volume, and two, it has to have mass. So think about it. The air filling up a balloon, the food on your plate, even a teeny tiny grain of sand, they all take up space and they all have mass. So, yep, they're all matter.
All right, science detectives. It is time to crack open our first case file. Our subject? The solid state. As you're about to see, this is the most definite, distinct, and, well, rigid form of matter out there.
You can actually try this one right now. Seriously, go ahead and grab a pen or a book. Now, if you trace its outline on some paper, what do you see? It has a fixed, definite shape, right? Super clear boundaries. That shape isn't just going to change on its own. That's your classic clue that you're dealing with a solid.
And this tendency to keep a fixed shape, it has a cool scientific name: rigidity. A solid might break if you hit it hard enough, sure, but it's always going to fight to keep its shape. That's what makes a solid a solid.
Okay, let's throw a little curveball into our investigation. What about a rubber band? I mean, you can stretch it, you can change its shape really easily, so does that break our rule? Is it not a solid? What do you think? Surprise! It is absolutely a solid. And here's the secret: a rubber band only changes shape when you're applying a force. The second you let go, what happens? It snaps right back to its original shape. And if you pull too hard, it doesn't just stretch forever, it breaks, just like any other solid. So, case closed on that one.
All right, here comes another tricky suspect: the sponge. We just said that solids are rigid and hard to compress, but you can definitely squish a sponge. So what is going on here? How on earth can that be a solid?
The mystery is solved when you look a little closer. See, a solid, like a rock, is incompressible because all its little particles are packed together so tightly. But a sponge, it's full of these tiny little holes with air trapped inside. So when you squeeze it, you're not actually compressing the solid part of the sponge, you're just pushing all the air out of those holes. Pretty clever, huh?
Case file on solids solved. Now let's move on to our next subject, liquids. These are the true shapeshifters of the matter world.
So check out this experiment. Let's say you measure out exactly 50 milliliters of water. Then you pour it from a tall glass into a wide bowl, and then from the bowl into a skinny vase. What happens? The amount of water, the volume, it always stays 50 milliliters. But its shape? It changes every single time to perfectly match whatever container it's in.
This awesome ability to flow and change shape is called fluidity. Because liquids aren't rigid like solids, they can flow. That's exactly why we call them fluids. They're like masters of adaptation, always taking the form of their surroundings. And get this fluidity has some incredible real-world consequences. It allows gases, like the oxygen from the air, to actually mix into and dissolve in water. This process is called diffusion, and it's the entire reason that fish and other animals can breathe and survive underwater. So cool.
Time for our third and final case file, the gaseous state. Get ready to meet the great escape artists of the matter world.
To really understand gases, let's imagine one last experiment. So picture 3 syringes. We fill the first one with chalk powder, that's our solid. The second one gets water, our liquid, and the third one, we just leave it filled with plain old air, our gas. Now, if we seal the ends and try to push the plunger in on all 3, which one do you think is going to be the easiest to compress?
And, yep, you got it. The plunger and the syringe with the air moves so easily, while the ones with the solid and the liquid, they barely budge at all. This shows us a super important property of gases. They are highly compressible.
You can squeeze them into a much, much smaller space.
And this high compressibility thing, it's incredibly useful in our everyday lives. It's how we can cram a huge amount of cooking gas into a small cylinder, or enough compressed natural gas, or CNG, to power a whole car. We're just squeezing a giant volume of gas into a tiny little container.
Here's one last piece of evidence for our gas case file. You ever notice how the amazing smell of hot food travels all the way from the kitchen to your room in just a few seconds? That's because those tiny aroma particles from the food are in a gaseous state. They're moving at super high speeds, mixing with the air and spreading out really, really fast to reach your nose. That rapid mixing is diffusion in action.
So, we've investigated the unique properties of solids, liquids, and gases, but we still haven't answered the biggest question of all. Why are they so different? To find the answer, we have to zoom in. I mean way, way in, and enter the secret world of particles.
This table pretty much sums up everything we found so far, right? Solids have a definite shape and volume, liquids have a fixed volume, but they take the shape of their container, and gases, they have no fixed shape or volume. But look at that last row, particle force. That is the huge clue that tells us why they're all so different. It all comes down to the forces of attraction between their particles.
And this is it, the big reveal. The real difference between solids, liquids, and gases is microscopic. It's all about how their tiniest little particles are arranged, how tightly they're packed together, and how much freedom they have to just move around.
Let's break it down. In a solid, you can see the particles are all locked into place, just vibrating. They're packed together super tightly, and that's what gives solids their rigidity. In a liquid, the particles are still close, but they can kind of wiggle and slide past one another. That's what allows them to flow. And finally, in a gas, it's a total free-for-all. The particles are really far apart and they're just zooming around randomly at crazy high speeds. That's why gases fill up any container and are so easy to compress.
So we've cracked the case. The secret to the 3 states of matter is all about how their particles behave. But this leads to one final, really fascinating question I want to leave you with. What do you think happens when we add energy, like heat, and make those particles move even faster? That sounds like a mystery for another explainer. Thanks so much for joining the investigation.